Oh, hey, morning, everyone. I'd like to welcome you all to our KETIV AVA Autodesk Virtual Academy. Thanks for attending today. My name's Eric Curtola. I'm a Territory Account Manager here at KETIV and first-time AVA presenter. With me, I've got my friend and colleague, Nigel Ambiak, AVA veteran, you could say, and application engineer, member of our Lifeline support team. With us today, we're excited. We've got a special guest. We've got Julio Alfaro. He's a technical specialist with Autodesk joining us. So thanks for being here, Julio.
My pleasure. I'm glad to be here.
Thanks. So I think some of you on the call or on the presentation may be wondering why advanced steel? Isn't that a tool for people doing structural detailing, people maybe who are building the next Sears Tower, Empire State Building? The goal today is really just to give you an overview of what advanced steel is and how manufacturers and people in the AEC industry are using this technology. I guess some of the key takeaways, Nigel, we want to leave everyone with is, again, what is advanced steel, how it's being used, what problems it's solving, who's using it, and to impart on you guys the knowledge of whether or not you should or should not be considering this technology.
Definitely, and the poll that's up on the screen right now kind of has a general overview of some of the major steel industries, what things you can use advanced steel for. We just want to get an idea of what the audience base looks like, so we can definitely target this particular presentation to those groups of people. So it looks like most of the people are falling within that miscellaneous steel and structural steel sectors, with a few people in some of those larger.
Right, like Nigel says, the polls are kind of a newer thing. We're trying to do more. We want to try and make these as personalized and kind of collaborative as possible. So
sure.
It's a good idea, or at least our best idea, to kind of get feedback from the attendees.
Definitely. And if you do have any questions, as usual, feel free to type them into the chat box. You'll be able to type those in. We'll be able to answer those either during the presentation or during the dedicated Q&A session at the end. We'll make sure to get to all of those for you.
Great. So I know Julio is going to show us an actual live demo today to actually kind of show some of the benefits and key features of advanced steel and how it might help the workflow. And with that, we're going to go ahead and turn it over to Julio and take it away. Julio, before you get started, just for some of the people attending this presentation who might be unfamiliar with advanced steel, can you go ahead and give everyone just a high-level overview of what is advanced steel and maybe the history on it?
Okay. Yeah, no problem. Just to kind of recap on what advanced steel, why advanced steel is with Autodesk now. So advanced steel, when Autodesk was looking for a software to do steel detailing, they looked at a numerous amount of software, and the one that qualified or was a best fit for Autodesk was advanced steel because of its programming, because of the way it works, and most of all because it originally ran on CAD-based platforms. So just to give you an understanding, advanced steel runs on top of AutoCAD. And this is why Autodesk had a big interest in it. Autodesk has had advanced steel for the last 3 years now. Each year, Autodesk releases three updates in a year. So when Autodesk bought the software, they not only bought the software, but they bought the engineers or programmers who work on the software. So we've got well over 14 years of experience inside the software employed by Autodesk.
So thanks, Julio, what does advanced steel do? What is it used for, Julio, typically?
Typically, advanced steel will help you and do structural steel detailing for fabrication of steel. So, regular workflow is going to be a engineer or an architect doing his design inside of Revit, and then doing drawings or whatever. But Revit will not give you detailed drawings like advanced steel will. In other words, it'll give you center-to-center dimensions for beams, columns, and so forth, but it will not give you the exact cut of copes, holes, tags for beams, and so forth. That is where advanced steel comes in. You can get a model straight from Revit, import it into advanced steel, and then start doing your details, because the model will be one-to-one from Revit. assuming that that's the process that you're following, right? If you are actually starting from scratch, like we will be today, because today is going to be a model that's going to be started from scratch. If you're starting from scratch, there is other tools that help you in creating the steel, modeling the steel, and then creating the drawings that you need so you can fabricate, buy, and produce your steel.
Fantastic. Yeah, that's awesome. And like you said, it's not just for civil infrastructure. So not necessarily somebody using it for a skyscraper or a cell tower. We also have manufacturing customers who are maybe manufacturing industrial bulk handling equipment. They've got long stretches of steel there. That's structural steel. Or maybe you're in the plant space and you've got platforms or water tanks. You've got stairs or that miscellaneous steel we talked about just kind of around there. That's also something Advanced Steel helps with.
Yeah, for sure. So without further ado, let's go ahead and hop into AutoCAD here, and we'll see what Advanced Steel is all about. So Julio, if you take it away.
Excellent. So just to give you a brief overview, first create a grid. I'll start creating some columns. I'll move on to some beams, connections. Then I'll do a stair, some handrail, and a cage ladder in that order. If there's any questions, feel free to ask. I will try to answer them as best as possible. Nigel, just let me know if I need to stop or anything, and we'll take it from there. Okay, so basically this is your workspace. If you're used to a black background for AutoCAD, that's just in your options. This is AutoCAD. Everything for here is just AutoCAD. Nothing is different except for the fact that you have all these different ribbon-based icons that help you with Advanced Steel. So a lot of our customers like to refer to Advanced Steel as AutoCAD on steroids, which is kind of true because it helps you create steel and do the drawings a lot faster. So just to give you an overview here, if you create a line and tell it that you want it to be 10 feet, obviously you just type it in a command line. You got a line that is 10 feet. If you select that line, it's got 3 nodes on it. Same goes for a beam. If you select the beam icon, you tell it that you want it to be 10 feet. It creates a beam that is 10 feet. Right click, and then this comes up. This actually has more. So here's, like I said, the steroids. You can do a drop down to select the type of beam or size of beam that you want. It automatically changes in the model, which means that you will also have the properties change here for that beam. So all this is the same information that you find inside that AISC black book that people like to go through for the most part to get all that information. Well, it's readily available right here. Okay. You also have other options here for positioning, top of steel, rotation, naming, all of that. We'll get into that through the model. I just wanted to make sure that you understand how to create a simple beam is. Okay, so just get rid of this stuff right here. Okay, and we'll start with the basics, which is just creating a grid. And I'll just here's my icon for the grid. Building a grid. I'll just tell it that I want it at 0 location. Okay, so there it is. So right now my grid is 60 by 40. I can specify a change here. If I wanted it 60 by 80, I could do that as well. And it just hit enter and it creates my grid. Currently the grid is set out to do numbers on one side and numbers on the other. If I double click on the grid, I can actually make this into, again, the grid is also interactive, so it has properties. So right now it has numbers. I can change that to letters. I can actually have an edging on it. I can move this icon, this grid out and make it into more divisions. So right now you got 4. Let's make it 5. Now you got 5 equal divisions. So they're at 20. Okay. So again, it's that simple to create. As far as your creating your objects, the ribbon is pretty well organized. Everything in Advanced Steel is actually pretty well organized. So you got your Home tab that has quite a mix of icons, and then you go in order too. Then you got your objects for creating steel, grading, plate, and so forth. Then you got extended modeling where you can do some of the miscellaneous and some other tools for checking and stuff like that. And finally, you got your output, which is your drawings. So we'll go in that order. So right now we're in objects. And the first thing I want to create is a column, which is right here. Okay. So if I click on this, and notice I can be pretty far away, and because of the snaps from AutoCAD, I can literally snap to the middle point between those two axes, and I can put my columns there, and I'm going to put them all right there. Now they're coming. Actually, I missed that one. Sorry, guys. Now I actually set it up so that it would come up to top of steel automatically. But obviously a column would have to be at the center of the column between those two axes. So I'm going to right click and go to positioning and then select the midpoint, and notice all of them moved at the same time. Okay, so the change for one is the same for all, as long as you have them selected. If you want to change the size of the column, you can change it here. 12 by, see if I got this number right. Yep, 12 by 26. You can type it in as well. The other thing I did want to show you is once you start creating your beams, let me get rid of this one. Once you start creating your columns, if you want to find out what the size of the column is, you can go to the properties, and it tells you exactly right here what it is. Okay. Now I also have settings on my column on my program where it tells me the information as long as the minute I hover over it. Once we start creating drawings and doing numberings, you'll see more information pop up right there, like the part number, the model rule, and stuff like that. So I'll go over this again later on so you can see the difference between right now the information is displaying and the information it will display once we have more in there. The next thing we can do is create a beam, which is this right here. Now, to make it easier on myself, I want to snap to those axes that you see right there. So I'm going to clear out all these and just do the node. And then once I come in here, even at a distance, I can snap to those real easy. And notice it's a continuous beam. But when it gets created, it's individual beams. It's not one whole polyline. Some people confuse that continuous beam as a polyline. It's not. It's actually just letting you create the same beam throughout without stopping. Again, the beams will always come in at the mid section. You can right click and then you select them all. Right click, go to the properties, and go to positioning, and do top of steel, and now you are at top of steel. Okay, it's pretty simple. All right. Let's do. Let me see here. This is a 16. I'm going to move this level. So remember, AutoCAD is still in play here. So you can use your AutoCAD commands by just selecting objects and saying that you want to move them. Like in this case, I'm going to move it down. I'm sorry, I didn't want to move it. I actually wanted to copy it, but I moved it. So this time I want to copy it. So I want to copy the selection up 36. Now we've got two levels there, right? Oh, excuse me, guys. I apologize. I have a cold right now. All right. So that's as simple as it gets for creating columns and beams. Let me check the panel, see if there's any. I don't see any questions. Let me know, Nigel, if there's anything that comes up.
I will. I'll let you know if anything pops up here.
Thank you. So one of the other things before I move on to connections, I'm going to create a simple line here, and then just because I do have my midpoints off. I'm selecting the midpoint of that axis and going to the midpoint of the other axis at the other side. Come on, select. Okay. So this is just a simple line, right? I'm going to copy this over 48 inches, and then, oh, I'm too fast here. Okay, so notice this is just simple lines, right? So imagine yourself receiving a drawing set from your customer that is in AutoCAD based, so they're just a plan view of drawings. You can get that plan view, put it up to the right elevation, select those lines, and then turn all those lines into beams. So right now it's asking me, do you want to erase those lines? I'm going to say yes, and there's my beams. Okay, they're 12 by 26s because it's the last one, the last selection I had. Positioning, let's do it on top of steel, and now we're actually ready and set to create some connections. I'm going to change the view as well so you can see that you can have a different view style. So as you can tell, within the last 18, maybe 10 minutes actually, because we did talk, within the last 10 minutes I created a sizable frame with some grid, so it didn't take very long. Now, okay, well the frame is good. Now let's start creating some connections, okay? Because that's going to take us to the next level, which is going to be creating the drawings, right? So for that, we're going to go to the deep connection vault here. Connection vault is actually where Advanced Steel keeps all of its connections that will help you make the design work. So the first tab right here is called plates. We have this one here called base plate, right? And we have a couple of different ones that can apply to different types of columns. Let's create the first one. All I have to do is select my column. It's asking me if I want to do additional concrete objects. At this point, I don't have concrete objects. I'm going to say no. And it drops in a base plate for me with make sure that I go to the right tabs here, with the anchors, some washers, and so forth, right? It's actually cutting the column so that whatever we were at finished floor, we're still at finished floor, but it's cutting the column through that plate, okay? You have the ability to save these connections to a library. So if I wanted to call, as you can see, I have Rob and Luke. I don't remember who Rob and Luke is, but I have those still saved here. And I can call them whatever I like. All I have to do is hit Save Values, and then it saves it to your library. So that means that you can utilize these connections later on in a different project without having to start from scratch. And that'll be the same thing throughout Advanced Steel. Okay, the connection can be modified throughout here. As you can tell, it's a 1-inch thick plate. Here's the dimensions for the plate. The anchor is a 3/4 inch anchor, U.S. headed anchors. It's 1'4" long. I can specify 1'2". As you can see, it changes right in the model. So every time I make a change here, it changes in the model. The other thing I do want to show about these dialog boxes is that they're very, very intuitive. They tell you exactly what you're doing. So 5 right here will change my dimension there, right? So if I were to put, it says 22, let's do 24. There's my dimension changing, right? 22. There's the other way. Right, so we understand the dimensions that are called out right here. We understand them here. Making the change here will automatically update your model. Okay. So it's very easy to go through those dialog boxes and make the changes. Okay. Now I'm gonna try to speed up this process so that we keep within time. I'm gonna go to so that was the connection vault, guys. I'll go through other connections in just a bit. This is the Advanced Tool palette, or the Modify menu, just like you would find it in AutoCAD. Except, again, this is a little bit more intense than AutoCAD. So I'm going to go here, actually this one here, sorry. This one here, it says Create Joint in a Joint Group, Multiple. So what this one's going to allow me to do is select this plate, and then go to the different columns that I want, and it'll create all those base plates all at once. Now, what's really interesting about this is that if I go back into this connection, and let's say the engineer has told me that I need a change on that connection based on the design. Let's say the headed anchors are no longer headed anchors; they have to be J anchors, round J anchors. I make that change to that one. It makes the same change to all three of them, to all four of them. Okay, so that's just something that can help you in your design. Okay, all right, cool. Let me go back to the connection vault. We'll finish connecting this, add a stair, handrail, and then we'll start creating some drawings. Okay. So the next thing that I want to go into is this right here. So right here, I'm going to create a couple of clip angles. Simply select your column and your beam, and then it automatically will create your clip angle for you. Okay. And then you do have options for, you know, whatever the size of the clip angle, whatever the weld, if you're actually welding to the to both, if you're welding to the main, or if you're welding to the secondary. Okay. You have options for top copes, bottom copes, all that stuff. Every one of these tabs will tell you exactly what you're doing and how you can change it. Okay. I'll move on to the next connection, which will be a simple shear plate, and then we'll start creating some copies of those. So here's the shear plate commonly used in the US. Column, and then select your beam, right click, and then automatically you get your shear plate connected. And then notice that all of my modeling was done to the center of the beam, which is how you want to model. But the connection will actually cut it and cut it back just what you need. Right now there is a dimension right here that is a 1/2 inch cutback, which you can adjust as needed. Okay, but it will cut all the way through and then 1/2 inch back from that face. Okay, so it says right here, from face. Okay, so again, these connections are very useful and very easy to use. Okay.
Hey, Julio, I'm going to cut you off real quick. I noticed a couple questions just piling up here, if you don't mind.
So Terry asked, can these files be exported to Inventor?
The when you say files, do you mean the model?
Yes.
Yes, they can, as solids.
Okay. And they're coming as solids with essentially like dumb solids, no model tree, all of that stuff. And then
That is
another
correct.
question. Okay, another question came in from David, and he's just wondering where this library of profiles and connectors comes from, and I'm guessing that's like ASTM standards.
It's yeah. Sorry. It's they are stored in a database inside software, and these connections were developed per the AISC standards.
Okay.
Okay. They're not supposed. Okay, so just so I can explain that correctly, just because I created that clip angle right there, it is part of my library, and you can meet AISC standards. The software will not correct you if you change this and make it incorrectly. If I'm explaining that, let's see, vertical bolts. So if I were to go here and tell it that I want 5 bolts, it'll make 5 bolts.
Mm-hmm.
And AISC says that it's 3 bolts, and you can still make 5 bolts if you want. AISC says that you can do 3 bolts on this size of the beam, and 3 inches from the top, and 3 inches in between. Okay, that's where it's basing it on. If you see it here, does that answer the question?
Yeah. Perfect. Thank you, Julio.
Thanks, Julio.
Okay. Cool. Is there any other?
You know what? We've got a. Sorry, I keep accidentally clicking the mute button. We've got a couple other ones, but let's keep moving, and we'll address those a little bit later.
Not a problem. Okay, so let me quickly copy these over so we can finish up, framing this, and then I'll create the stair and handrail. So I'll just, do this. So here, and then it is, let's see here, I want it on this column and this column, and I want it on these beams. Okay, so you'll see the connections show up on the opposite side. Okay, so everything's framed up right there from that one connection. Okay, I don't need those. I can now go ahead and actually create this one on the opposite side. So I just need to copy from one selection. So all I have to do is select one object, right click, and then I pick my columns, which is the objects that are receiving that connection. And then I need to tell it where I want those connections to land. So this is the beams that I want it on. That doesn't have a reference. And I think this one. Yeah, this one too. Okay, and you'll see the connections come in. And right now it's asking me if I want to separate from the original one. I don't want to separate it. The reason it's asking is because the way the original one is facing is the opposite end. It's facing a different direction. So as you can see, everything is pretty well connected now. Okay, with the exception of here. I'm going to connect this because when we do some drawings, I'm going to do a change here that I think you guys will get a good kick out of. So let's go back to the connection vault and just do a shear plate here and here, and then do the same thing here. And then do some clip angles here. Not sure if it works for both yet. No, it doesn't. So you can see you can pretty much connect everything in a short period of time. Now, the one thing that I did want to show about this is that you can check some of your, actually it should probably be better to look at this one here. You can check some of your connections by going to the joint design. So notice this one has a not calculated value yet. So that means that we haven't run a calculation check on this. So based on the parameters that the engineer gave us, we're running per AISC code or Euro code. You can also plug in your own values right here. But if I were to run a check based on what the engineer told me, I can hit check right here, and oh, this one says it passes. So there's no failures. Let's go back to vertical bolts and make it 2 bolts, and let's do that again, and we'll make it fail. See, so it's telling you that it's failing, right? And it's just telling you right here, angle checking secondary conditions. If you want a more detailed report that you can send back to your engineer saying, you know what, this is not working based on my software, you can run that report. It'll tell you exactly what it's doing, the standard LRFD. It'll tell you the 2 elements that it's checking against, and then it'll tell you all the different positions where it's checking. Okay, and everything that says okay is everything that's passing. And then once you get to the red, that's where it's failing. Okay, you can literally tell your engineer, you know what, can you verify this and then give me an alternative. Whoa, not 36. Okay, there we go. All right, so so the entire frame is pretty well connected now. I'm going to put in the stairs and rails, and then that way we can start doing some drawings, which is probably the most interesting part, right? So I'm just going to utilize AutoCAD in order to make my stair here. So I'm going to do, let's see, 52, and I think this is 13 feet. And then we can do this one. 14 feet. I don't know if that's going to be a good-looking stair, but we can try it. Okay, so basically, I'm just going to use those lines as reference points. So as you can see, you can use AutoCAD to your advantage. Okay, so the fact that you have AutoCAD here, use it for your construction lines is a good advantage. This is one of the reasons why a lot of the detailers out there like this software, is because you can use AutoCAD as well. So I'm using the stair macro here, and all I'm telling it is that I want to use 2 points, which is my endpoint and then my endpoint here. And then you'll see the stair drop in automatically. It's a pretty steep stair. Sorry about that. I guess I could have made it shorter, but it's still good. So basically here you have an option for libraries. Again, all of the Advanced Steel software has the macros with library options. So you can save your values here. So I can save this one and then call it something if I wanted to. Okay, and then now that value is saved, and it's also available for me in a different project. So the idea behind this is for you to go through here and make the changes that you need for the stringer. As you can see, there's options for different types of stringers. You make your changes for the stringers, for the riser, everything that you need. Here's your steps, your tread types. There's 24 different tread types, but you can add more to it. And then save it to your library so that it's available to you in a different project. Okay. All right. Just the landing, the top landing, I'm actually going to extend it 52 inches.
And doing something like this in Inventor probably take a considerable amount of time, unless it's already like automated via something like iLogic or something beforehand. But that automation would obviously take forever.
I don't think we have too many people who have rules set for stairs, for miscellaneous steel.
But it's already in here. It's pretty awesome.
Yeah, no, Advanced Steel comes with it. That's awesome.
Yeah, everything's already set up in there, including materials and all that stuff. So it's, just a little thing here. The pan itself, again, you have 24 different pans, so you have grading, wood planks, you have plate and all that stuff, and even the plate themselves. Let me see. So here's the pan itself, right? And it's got a lip on top. If I wanted to modify this, it's just basically here. Here's all the numbers that tell me how to modify it, and I'll show you exactly how simple it is. So number 8 is that lip right there. I'll zero that out, and that lip is gone. Right? So it's
all of the steps?
Yes, all of them except mine included the first one, but not the last one, because the first and last are actually always different on any stair. Mm-hmm. So it has an option for the first and last step. This is step. So here's step top, and see that checkbox? It was checked. So whatever I did to the original one applied to the top one, but the step bottom was not checked, so that one did not change.
Gotcha. Hey, Julio, a quick question for you. Jay asked, will Advanced Steel do a helical stair?
Helical?
I.e. helical. Sorry, guys. It shows you my experience. A helical stair, i.e. for a tank.
Yes. Yeah, we do have that. It's an option right here. It's called spiral staircase. I'll drop it in. I'm not good with that one because I don't know what the parameters are. But here is a, let's see, a 24 foot, and then it's telling me left or right, so I'll just do left. And then the radius, let's see, the outside radius value, let's do 36, and then we'll make adjustments as it comes in. But it'll create everything for you, so there it is. So you can remove that center, the column, central post just by unchecking this. Just give it a minute to update. So there it is, right? And then you can expand the radius to, let's say, 300, and then make this one I don't know, 20. Okay, so it'll expand whatever way you want.
Cool,
Okay.
definitely.
And we've actually done stairs for tanks. We have a video on YouTube that I can send you for actually a tank stair that we've done.
For sure, and I'll definitely get that sent over to Jay after presentation. Cool, thanks, Julio.
Awesome. All right, cool. So as you can see, we've got the stair itself. We actually have connections for the stair as well. Let me go back to my UCS world move, and I'll just put my UCS, my points. I forgot about the points. Put my UCS right there because that's where my finished floor is at, right? So I want to go to my connection vault, and in my connection vault under miscellaneous, I just want to make sure that you guys are aware that we have connections for almost everything. So, and whatever we don't, you can make up yourself with custom connections. There's custom connections available for the customers too. So if you do the fly out right here, you got an option for the stair anchorage. You can select it, select your stringer, and I want to tell it that the nosing is my reference point, so I'm going to say endpoint, and no, actually it's node. No, you know what? I can't see it because it's on perpetual. Select my stringer, tell it yes, and there it is. So then my anchor becomes right there. I can go to general. I can tell it to do the angle on the other side so it's out of the way. And then I can come in here and actually tell it that I want a cut. Right now it says none. I can do cut only, or I can do cut and plate. Set to an inch and 3/16. Let's do about 12 inches, or maybe 11. Okay. As you can see, there it is. It's cut with the angle right next to it, the anchor, and everything is all set. Okay. So you do the same thing to the opposite side, and then connecting on the on here on let's see, channel to. So you just think about the connection the way it is, right? So channel to a beam, I'd probably use a shear plate. So pick my shear plate, pick my channel, and it'll make the connection with the right cope, the holes, and the cope at the bottom as well. So even though this channel is part of a macro, and this beam is not part of a macro, it'll still make the connection. Okay. All right. So the next thing I said I was going to show you guys was a rail. Let me change the view again. And you know what? I'm going to actually change some of my snaps to make it easier. Okay. So I'll create the handrail right here. So here's my handrail macro. And all I have to do is actually pick the objects in which I wanted a handrail to be dropped into. And then I have to give it just a starting point and a finish point, which is right about here. Okay. And then after I'm done, it'll create my macro for me. Do I want to give it a reference point? No. Just create it. Okay. So first rail that's created, there's rules inside of the macro to create the rail, right? So right now it's got pickets. I can turn those off real easy. All I have to do is select this, and they're off, right? I have options for the pipe, the type of pipe that I'm using. If I want to use angle, I can use angle for the posts. Post layout, I can do that as well. Right now it's set to 8 feet. I can do it to 48. My post layout changes. Okay, I can do glass panels in here based on this this sort of configuration. I have to add the glass panels, but I still have the configuration. The returns are right here as well. See handrail and handrail, and right now it's set to nothing. You could do a loop. You could do a loop return. Okay, and anything that's not right here, if I wanted to do nothing, and I want to do just a I'll go straight out right here. Let's see, 18 inches. I'll go back 6, and then I'll go back 12. Okay, so basically I can grab these, turn them into beam from line. I'll say I want to erase those. Yes, that's fine. And then do match properties, which is inside of AutoCAD. Select this pipe, and then select this, this, and this, and now they're matched. Then all I have to worry about is those connections right there, right? Which is available in Advanced Steel based on this connection here. There's your miter. Oops. Select the beams. Then if I don't want a miter, I can do a elbow. And where's the other one? Here. And my last one. And then I can do again a knee and tell it that I want it radius. So I can easily come and create any shape that I want, even if it's not in the macro, and make it part of that macro. Okay. And then once again, I'll repeat it. This thing has this macro has the option for library, so you can save that. I'm just going to go to the handrail real quick so that when we create our drawings, I want this workshop, so it's one whole drawing. Okay. So that's the easy way to create just a simple handrail. I'm going to move on to drawings next. Before I do that, I'm just going to create one more handrail so you guys can see this. I'm going to select my beams, so 3 beams, right? And then I'll select my starting point, which is here, and my finish point, which is here. And then no. And then I'm not sure how long it will take you guys to create a handrail going across the platform like that, but as you can see, I did it with 3 clicks. And I can modify that as much as I want. I can have it side mounted if I wanted to. I heard something. Oh, okay. I can have it side mounted if I wanted, top mounted, side mounted on the other side, pickets on this, anything that I want. Okay. All right, I'm going to hit save on this so we can start creating some drawings. Save as. Let's see here. Create a new folder. 11, 4, 6. Put it in this folder already, so it's not what you're talking about. Oh, okay. Right there. What the heck? Save as. Desktop. There we go. And I want to make sure that I did save it. There we go. Okay, cool. All right. So that's saved. The next step would be, so just to kind of review, we started at home, we created some, grids, columns, and beams, then the connections in that order, then the stairs and the handrails. So that would be a process on creating, a model. The next step would be going to the Output tab and doing some numbering. The numbering options for all these parts is very, very simple. You won't have to go look and see anything, if anything's repeated or anything like that, because the software will take care of it for you. I'll hit apply and I'm selecting this numbering sequence. I'll hit OK. And then everything's automatically numbered for me. And as you can see, I can pick any one of those and it'll show me everything that's in there. Okay, so if I want to create a quick drawing off of this, let's say like this, on ISO, I'll just go to the tool palette, put my UCS at that position, so I'm looking at that way. I'll go to my drawing styles and my 3D views. In this one, entire model without labels. Let's do that one. I'll say the default. And then the most important thing is your document manager. This is what's going to control your drawings. It's what it's going to let you see what they are and where they're at. So as you can see, that drawing was created pretty quickly. It's a little bit outside. I can actually move that if I want to. Okay. But there is the representation of that ISO. Okay. All right, cool. That's the wrong. There we go. Now, if I wanted to create a plan view, all I have to do is I'm going to create a couple more drawings so that we can have maybe some QA. I'm going to move my UCS to this position here. Actually, world first. Okay, and then I'll just create a real quick plan view of this floor. Okay, let's go back to drawing styles. And then we have a section here for elevation and plan views. So I'm going to select plan view full, and it's going to give me details of the beams and so forth. So I'm just going to go plan view full, and then create using defaults. It's going to tell me what do you want to include. So I can include the stair, or I can not include the stair. So I'm going to actually turn this a little bit and include just like half the stair. Now, actually, I'm explaining this incorrectly. This is based on a certain dimension up and down, so the stair is not going to come in anyways. So let's go back to our document manager, and there is my second drawing. Let's go back and open this. And there are all my piece marks. So if I click on this beam, it's B8 W12 by 26. I requested this one with no dimensions. There are drawings with dimensions. If there are drawings that come in with no dimensions and you wanted to add some, all you have to do is click on this here, select the beam here, and then go from, let's say, the center here to center here, and it creates your dimension for you. Okay, so creating dimensions is really simple. Creating labels, creating notes, and all that stuff is really simple again. Okay, so that's just a simple plan view. Close this because it keeps popping up. I'm going to just create a beam drawing, because what we're going to do with this one, we're going to look at the revision stage of this. Okay, so right now this beam is actually 3 foot. It's overall is 4 foot, but the cut section is 3 foot 10 3/4. We'll create that drawing. So I'm just going to go to my assemblies here, beam, select it, and then I'm going to modify this because I need a different prototype that includes a bill of materials. So I want it on this here. Actually, I'll put it on this one, and just click OK. Now, I can actually go back to the output and go to the document manager, or I can select that beam and then right-click and tell it to show me that assembly detail. And what it's going to do is it's going to open up that drawing. Okay, So notice that this beam has a couple of things, right? It has the radius value here for all the copes. It has the dimensions. You can change these dimensions as needed. Okay. You can add more dimensions. You can do whatever you want to it. Right now, I just want to point out that it is a 3 foot 10 3/4 beam. Okay. It has its bill of materials here. If it had anything attached to it, it would show it there too. And it calls out the bolts that are needed for that beam. Okay. All right, cool. So remember, 3 foot 10 3/4. So let's save this. And now what I'm going to do is actually, I'm just going to grab this beam because let's say that the engineer told me to move it over. Excuse me. 24 inches. So notice what happened. The connection here moved with the beam, okay? And then this connection also moved with the beam, but it also stretched this beam, okay? So what we're going to do now is actually go to that document manager and note that every drawing that needs an update based on that change is reflected here. Now the reason these two need a change is because, I'm sorry, this one and this one, these are erection drawings, so any change that I made to that beam will, it actually needs a change too. So I can actually do a force update, or I can do an update revision. Do an update revision and tell it to add a revision, tell it who did it, and then tell it stretch beam or move beam. So here's your revision, but it's doing two things here. It's creating that revision, and it's creating a backup of that original drawing. Okay, so it'll put a backup of your original drawing in a folder so that you have a reference to go back to your customer and tell them, you know what, you owe me more money because you made me change this drawing 10 times. And if he disputes it, you can show him the history of those drawings. Okay, once you hit OK here, then the drawing starts updating. And there is drawing 3A with an A revision on it. Let's open that drawing. And then notice that now it is 5 foot 10 3/4. The overall 6 feet. There's a theta showing you that. The bill of materials also updated. And then there's obviously a location for this. It's updated, so that's why there's the theta right there. But it lets you keep track of all the changes, and you don't have to worry about trying to figure out where they're at. Now, it did add this dimension. This is the original dimension. You just delete it. And then you can also go into labels and dimensions and delete a dimension point. Now it's updated.
Hey, Julio, quick question.
So overall, it took me 2 seconds. Yep.
Okay, quick question. I see him kind of piling up here, and we're getting towards the end here. We're going to wrap up. But Ray asks, what is the clouded area? Clouded area around the bolts.
Around the bolts. So remember, there was a little. So because the beam was stretched. So remember, here's the highlight right there. So if you guys can see the red axis line, because this beam was stretched, then this is a new location. Literally, the software is considering this as a new location. So it's telling you that you know, this is the new location for the beam. It was at 3 foot 10 3/4. Now it's at 5 foot 10 3/4, and there's your dimension right there. That's why it's clouded right there. Yeah, I'll wrap it up right now. So basically, I just wanted to point out it took me 2 seconds to update this drawing, even though the model was updated. I didn't really do anything to the drawing itself except remove a dimension. You know, that's as simple as it gets for creating drawings. Even stairs themselves. I'll just create a real quick stair before I wrap it up. Drawing styles. So we have, just to point out, you know, different drawing styles that are available for us. So here's one for ladder, railing, stairs, you know, stairs at UCS and so forth. So in this case, all I'm going to do is move my UCS, put it at world, move my UCS here, and then turn on, let's see, turn on Y, and then turn on Z. Okay, so all I have to do is now create my stair by selecting that and then one of the points, and then just create by default. And let's see if I didn't do that upside down. And there is my drawing right there. And as you can see, the drawing itself is literally very clean because it's telling you all the different piece marks. It's telling you the dimension for all those points right there. It says 18 at 1 foot and 1/16. It's literally framing the entire stair to tell you exactly how you're going to build it. Okay, gives you a bill of materials here for all the parts that you need, and if there's any bolts as well. Okay, so again, the drawings are very intuitive, very well prepared. That, however, does not mean that that's where it ends. That means that you can actually get into customizing your drawing style so that they can output exactly what you need. So if this is too much information, you can actually modify it to do exactly what you need. Okay. Did want to show you guys one more thing before I do wrap it up. There is another palette that I did not touch at all. It is the advanced, no, not the advanced, sorry, the templates. And this one just, a lot of people get a good kick out of this because they don't like counting bolts as fabricators. So if I go to the bolt list and just click bolts, the software will automatically count every bolt inside this model for me. And then I can actually save that to a PDF or to an Excel drawing, I'm sorry, to an Excel file, and then send it to my vendor and purchase everything from this. And I'm not going to save that. I can also do the same thing with the material list summary, which will take into account every single piece that's inside here and give me a total what I need lineal. So all the 12 by 26s are listed here. Here's lineal length, yeah. So here's all the pieces and then the total of what I need for this size beam. I can send this to a vendor and they will be able to nest it and buy it for me. And the last one is a solids with pictures, not hardly any software. Now I should actually say I haven't seen any software out there with this type of a drawing list, because this one, what it does is it gives you all the different cuts. So this cut here is at a miter. You can send this to the saw and actually have the guy at the saw cut this at 45 degrees with a 1 7/8 inch offset from the end, so that he can get all his pipes done. Okay. That is what I have, guys. I hope that it's been informative. If you have questions, I'm all ears.
Cool. Thank you, Julio. We do have a couple that have piled up real quick.
Yeah, okay, so Conrad asked, speaking of tanks, and this is from a while ago, does Advanced Steel have capabilities to design, layout, square, rectangular, or round storage bins or hoppers?
Those are made out of plate, I believe. Yes, you can, and to some extent. Okay, because you do have the option to create plate, and it's right here. It's called create a twist and folded plate. So basically, you would create a plate from that. You can literally take lines and create those plates.
Let's see here. I'm just scanning a couple other questions. Most of them kind of revolve around the same thing. Oh, wow. Add this to frame generator. Autodesk should add this to frame generator. Maybe we should probably just take a quick minute, and I know we've done this in a previous AVA session, where we kind of talked a little bit about where frame generator leaves off and Advanced Steel starts, and I think it's kind of centered around the connections, but maybe Julio can tell us, or I guess expand on that. How does Advanced Steel differ from frame generator? Obviously, we've seen it with connections here, but
right.
Different with that.
So one of the things that and I'm a new inventor a while back. I don't know how much it's changed, but what you gain from the frame generator, I'm sorry, what you gain in Advanced Steel that's different from the frame generators, obviously the connections, right? You can do welded connections. If I were to do a frame here, I can actually go into this pattern here and start creating some welded connections. Okay, but if you are in a need for a connection with plates, angles, or anything like that, Advanced Steel can produce that a lot faster than the frame generator can. Now, the frame generator is done through lines. Advanced Steel can turn beams into lines, just like I showed you on this one. This is literally a frame, right? I selected those, turned those lines into beams. We do the same thing with columns. So there's similarities and there's advantages that you would have with Advanced Steel when you get bolted connections, and at the same time you can also do welded connections if needed.
For sure, yeah. And definitely I'm seeing Advanced Steel as being like a little bit more robust in regards to its capabilities. You can do a lot of the same things from what I've seen. You can do a lot of the same things you do in frame generator and Advanced Steel. Advanced Steel, you gain workflow by doing it sometimes in less clicks, or even being able to do things, yeah, like for example the bolted connectors. Like you're gonna have to create another part in Inventor.
Right.
For sure, and that's why Advanced Steel is definitely a tool for some people when it comes to certain workflows. I know a lot of people are working with like welded frames, but if you're not, and you're working with connected frames such as these ones, Advanced Steel is definitely the tool for you.
Yeah, exactly. Yeah, so it's definitely a tool. I mean, it has a lot of advantages. You can lay out your frames and then just start making connections. You don't have to worry about how the bolts are set up, because a lot of these bolts, they are set up like beams will need to be display type exact. So these are the gauge lines on these beams. So you may need bolts to be set up exactly on gauge, and notice these plates are set up with the bolts exactly on gauge, and that's dependent on the macro itself. So the macro has already incorporated all of this stuff right in there. You don't have to worry about it.
For sure, and I think that's it for today. If anyone does have any more questions, feel free to address those in the after webinar survey. Just to note, Advanced Steel is an AutoCAD product. It's just integrated within AutoCAD, not Inventor. If you do need to move these products to Inventor, they do come in as dumb solids in Inventor, and there's no like model tree or anything in that regard. But yeah, so that's Advanced Steel. If you have any questions, let us know. We'll definitely pass those on to Julio if need be, or we'll try to tackle them ourselves if we can. Again, we'd like to thank you, myself, Eric, and Julio, for being here.
And Julio, thanks for that presentation. We appreciate it. I know that covered a lot in about an hour. But yeah, thanks for attending, everyone, and thanks for that presentation. We'll see you guys hopefully next Thursday.
Yeah, next Thursday I'll actually be presenting. This is Nigel, for those of you who can't recognize my voice. I'll be presenting one of the new features in AutoCAD 2017, which happens to be like my literal favorite thing in AutoCAD 2017, which happens to be the ability to import PDFs with vector data and turn them into geometry and editable text and all the fun stuff. So we'll get back to a couple people here with some questions afterwards, but I think that's it for this week. So
enjoy the rest of your Thursday, everyone.
All right.
Thanks a lot. Have a good one.